Hey gearheads! Ever wondered what makes your car go vroom? It's all thanks to the engine, the heart of your car. This incredible piece of engineering takes the energy stored in fuel and transforms it into mechanical energy. This energy, in turn, powers the wheels and propels your car forward. Understanding how an engine works can deepen your appreciation for the marvel of modern transportation. Think of an engine as a small, controlled explosion factory. It repeatedly ignites tiny explosions to generate power. This process involves several key components working in perfect harmony. Don't worry, we'll break down each part in simple terms, so you don't need to be an engineer to understand. We'll cover the basics of how fuel is mixed with air, then ignited to push pistons. You'll learn how the up and down motion of these pistons is converted into rotational force. And finally, we'll see how this force is delivered to your car's wheels, making it move. So buckle up and get ready for a fascinating journey into the world of car engines. Let's start with the basics. Fuel. Cars mostly use gasoline, which is a cocktail of hydrocarbons. This liquid fuel needs to mix with air before it can burn. That's where the fuel injectors come in. These clever devices spray a fine mist of fuel into the engine's intake manifold. Here, the fuel mixes with incoming air. The air, drawn in through the air filter, is crucial for combustion. This mixture, now ready to explode, is drawn into the engine cylinders. Think of cylinders as small rooms where the real action happens. Each cylinder houses a piston that moves up and down. The piston's movement is what transforms the chemical energy of the fuel into mechanical energy. And how does the fuel-air mixture ignite inside the cylinder? That's the job of the spark plugs, which we'll discuss later. So we have the fuel and air mixed and ready to go. The next step, igniting this mixture to create the power stroke. This is where the magic truly begins. Now, let's talk about pistons. These cylindrical components are the workhorses of your engine. Imagine them as little weightlifters pumping up and down inside the cylinders. When the fuel-air mixture ignites, it creates a mini explosion. This explosion pushes the piston downwards with great force. This downward movement is the first step in the engine's power cycle. The piston is connected to a rod called the connecting rod. As the piston moves down, it pushes the connecting rod, which in turn rotates the crankshaft. Think of the crankshaft as a bicycle's pedals. When you push down on one pedal, it turns the crank, which rotates the bike's chain and moves the rear wheel. Similarly, the crankshaft converts the linear motion of the piston into rotational motion. This rotational force is what ultimately powers your car. But we're not done yet. Before the piston can be pushed down again, we need to get rid of the exhaust gas from the previous cycle and draw in a fresh charge of fuel and air. Section 4. Crankshafts and connecting rods. Transferring the power. We've talked about pistons moving up and down and crankshafts rotating, but how is this motion transferred? Well, this is where connecting rods come in. These sturdy metal rods act as the crucial link between pistons and the crankshaft. Imagine the connecting rod as your leg when you're pedaling a bicycle. Your thigh is like the piston, moving up and down, while your foot acts like the connecting rod, transferring the force to the pedal, which is the crankshaft. The connecting rod is attached to the piston by the piston pin, allowing for a pivoting motion. This pivoting is essential as it lets the connecting rod convert the piston's linear motion into the crankshaft's rotational motion. This smooth conversion of motion is crucial for the engine to function efficiently. The crankshaft itself is a cleverly designed component with offset journals to which the connecting rods are attached. This offset design ensures that as the connecting rods move up and down, the crankshaft rotates, generating torque. This torque is the turning force that ultimately powers the wheels of your car. Section 5. Valves, letting the air flow. Now let's talk about valves. These are like the gatekeepers of the engine, controlling the flow of gases in and out of the cylinders. There are two main types of valves: intake valves and exhaust valves. Intake valves allow the fuel-air mixture to enter the cylinder. When the piston moves down, creating a vacuum, the intake valve opens, allowing the fuel-air mixture to be drawn in. This intake stroke is essential for preparing the cylinder for the next explosion. Once the fuel-air mixture is ignited and the piston is pushed down, the exhaust valve opens. This allows the burnt gases to exit the cylinder. The piston then moves back up, pushing the remaining exhaust gases out through the open exhaust valve. These valves open and close at precisely the right time thanks to the camshaft. The camshaft is driven by the crankshaft and has lobes that push on the valves, causing them to open and close in sync with the engine cycle. This synchronized movement of valves ensures efficient engine operation. Section 6. Spark plugs igniting the action. We've got our fuel-air mixture in the cylinder, but how does it ignite? This is where spark plugs come in. These small but mighty components create the spark that ignites the fuel-air mixture, causing the mini explosion that powers the engine. The spark plug is screwed into the cylinder head and has a small gap between its central electrode and a ground electrode. When high-voltage electricity from the ignition system is sent to the spark plug, it creates a spark across this gap. This spark ignites the compressed fuel-air mixture, causing it to expand rapidly. This expansion pushes the piston down, starting the engine's power cycle. The timing of the spark is crucial. It needs to occur at the precise moment for optimal engine performance. Spark plugs are incredibly durable, but do wear down over time. The gap between the electrodes can widen, making it harder for the spark to jump. Regular maintenance, including spark plug replacement, ensures your engine keeps running smoothly. Section 7. The Symphony of Power. So we've seen how each individual component works, but how do they all come together to power your car? It's like a perfectly choreographed dance, a symphony of mechanical movements. The process begins with the intake stroke, where the piston moves down, drawing in the fuel-air mixture through the open intake valve. Next, the piston moves up, compressing the fuel-air mixture. At the precise moment, the spark plug ignites the mixture, creating a powerful explosion. This explosion pushes the piston down with great force, turning the crankshaft through the connecting rod. This is the power stroke. Finally, the piston moves up again, pushing out the exhaust gases through the open exhaust valve. This cycle of intake, compression, power, and exhaust repeats hundreds of times per minute, generating the power needed to move your car. This intricate process, repeated thousands of times every minute, is a testament to human ingenuity. Understanding how these components work together gives you a newfound appreciation for the marvel of engineering that powers your vehicle.